Hello, my name is Phil Sewell. I am the Strategic Security Architect for Voltage Data Privacy and Protection here at CyberRes, a micro-focused line of business. I'm joined by Neville De Silva, a Voltage Solution Architect, who's going to help me with a demonstration today. What we're talking about here is enabling secure data analytics for the Snowflake Data Cloud with Voltage Secure Data. I'm going to introduce you to the innovations within the Voltage Secure Data platform that makes this possible and explain the reference architecture for the combined Voltage and Snowflake solution. Neville will then demonstrate the capabilities live using Voltage Secure Data with the Snowflake Data Cloud. But first I'm going to explain why data privacy and protection is so important today. Let's look at the enterprise data trends that we are seeing in the industry and what our customers are telling us in terms of their platform needs, their data analytic goals, and maybe what you are seeing from your own organizations. So let's start at the top here. We're talking here about a massive market associated with the latest cloud analytic platforms. So many customers of ours who have invested in expensive on-premise data warehousing platforms as well as Hadoop ecosystems are now making a move of that data and the platform to the cloud. They're trying to get more value from their data in these large-scale environments. If we move around this diagram, this concept of cyber resilience, our organization is called CyberRes, and this is really relating to the fact that it's not a question any longer in terms of the possibility of a data breach happening. It's really to make sure that you are resilient, our customers are resilient when a data breach happens. So we were making this transition in the industry to one of cyber resilience. And here at CyberRes, which is a micro-focused line of business, we cover many aspects of cybersecurity and cyber resilience, from protection of data to detection of threats and evolving to protect. So at the heart of what I'm talking about today, and the center of this, really is the data. The data is most important to us and the Voltage Data Privacy and Protection line of business. So when we're talking about data protection, we're talking about protecting the individual attributes of data, protecting really your crown jewel attributes, and protecting that from not only outside modern attack vectors, but also from inside a threat. And all of this is heightened now by the data privacy regulations we are seeing worldwide that put even more emphasis on protecting your data with the best types of protection technologies available today. If we look at what the pandemic has done to the world, to our customers, to our own organization, we're seeing a huge amount of at-home work, remote workforces. And what that means is that there is a huge amount of data replication occurring today as people share data through cloud-based services. If there's some data that is sensitive in nature, that is getting replicated and duplicated in many, many places, which is then, of course, creating even a larger problem of risk associated with the volume of data. The impacts of a real breach keep going up and up and up. This number is from the Ponemon Institute in 2020, 3.86. There's lots of ways of looking at these numbers, but these numbers are significant in terms of the financial and economic impact of a data breach that your organization could experience. So that's important for us, for you, and for the industry. The cloud in general, of course, that is not slowing down by any means. So more people are moving to the cloud. But what we're finding is that it's not just one cloud platform that our customers are using. They're typically using a combination of on-premise systems and applications and platforms with cloud-based, multiple cloud vendors, whether that be the top three being AWS, Azure, and Google, or maybe others. So there's truly this idea of a hybrid IT environment now that we need to support. And then, as I mentioned earlier, the ever-growing global data privacy initiatives going on, the laws, the fines associated with that, all of that of highest importance to our customers and hopefully yourselves. Why does data privacy and protection matter to you and to us and to our customers? There's plenty of challenges today centered around data. The cost of protecting that data, of course, the high costs if there is a breach of that data, and costs associated with compliance and all the privacy regulations in the world today. We're always trying to get more value from our data, do this at minimum cost, while still reducing that risk of that breach, and lowering the cost of compliance. Ultimately, those business outcomes are important. So what's the challenge in getting from these challenges, addressing these challenges, and delivering true business value around data and data analytics? Well, there's technical challenges that kind of stand in our way. The types of attacks that are happening today, insider and external threats, are very advanced, and that means you need the latest and greatest ways of protecting that data. When we do protect data, that data is used in analytics, there's always a question of how are we impacting the business when we protect data with things like encryption. Our goal is to minimize that impact. There will likely be some impact, but trying to minimize that, and we're going to demonstrate that for you today. This fourth point on the technology side of things, platform integration and flexibility. What we mean there is we need the capability to integrate data protection into a wide variety of platforms and remain agnostic of the platform itself. That's ideal as it addresses the point made earlier that customers are not using just one cloud platform. They're not just doing the cloud. They need a data protection strategy that is enterprise-wide, protect the ability to protect data in one platform and then decrypt or detokenize that data in a different platform, maybe in a different cloud altogether. So we need to address that technology challenge. How do we do it? Well, the innovation of format-preserving data protection technologies within the Voltage Secure Data platform is a way to address this requirement. So what is Voltage Secure Data? It is a data protection platform that follows with the data-centric model. Again, that is meaning let's protect the individual attributes that are most sensitive rather than protecting an entire file system or entire database or entire operating system. Let's protect the attributes that matter most to your organization and leave other things in the clear. We do this with innovations around format preserving capabilities for encryption, hashing, and tokenization. We provide a wide variety of integration options to fit with many different use cases and platforms and technologies, whether that be direct API use, whether that is through functions that are available in the database level, file processing capabilities, and maybe even transparent options through the Sentry product. When we are doing encryption, there's always a requirement for encryption keys. So we have a integrated system for key management that is a stateless model. That means that there is no overhead required for storage of those encryption keys. Highly efficient model that we've had since the early days of Voltage Security. And as I mentioned earlier, platform support has to accommodate a wide variety of platforms, both the most modern platforms as well as legacy platforms as well. So what do we mean by format preserving technologies and ways of protecting data in this way? So here's an example that is a customer record, Leslie Roberts, and this person has a social security number or a national ID number, date of birth, and a credit card. So when we use the voltage secure data technologies to protect this data, you can see that they are truly length preserving. In most cases, they are data type preserving as well. So that date of birth is a real date of birth. You'll also notice that there is the ability to do partial protection of data. If we can preserve the last 4 digits of the social security number, then that extends the value of that data, perhaps for authorization purposes, without revealing the full 9 digits of that social security number. So the other thing is there are some very specific characteristics of these data protection formats we use. In this case, the credit card value on the right, the one that's actually tokenized or encrypted, is not a real a credit card number because it doesn't observe the checksum that we associate with credit cards. So a way to kind of now explore this a little bit further is to compare a couple of records. So this person shares the same last name. They have a different social security number, the same date of birth, and a different credit card number. Okay, but the social security number, if you notice, is only off by 1 digit, and it's actually one of the trailing digits that we're going to preserve. So what does that mean when we actually protect it? So if we look at now David Roberts and how that data gets transformed, you'll see that the last name in its transformed state is the same as Leslie Roberts. So that word Roberts is transformed the same way for different records. So this is what we mean by a deterministic algorithm. So the same input used with the same keys, the same system will produce the same output. This is going to mean a lot when it comes to data analytics. You also see the social security number is a completely different 9-digit number. Even though the original number is only off by 1, we're still using the full 9 digits to transform that data to the protected social security number. Date of birth is exactly the same transformed date of birth as Leslie Roberts above. Again, showing the deterministic nature of the algorithm. So let's expand this model as we get closer to looking at something that may more closely resemble larger data sets. In this case, we're going to look at a data set that is health-related information, and Neville's going to use this data in his demonstration later on. So as we say, it's all about the data. Once you start seeing this applied to real data sets, your data, it starts to become a little clearer for our customers and hopefully you. So here we have a patient record with first name and second name, date of birth, zip codes, and credit cards. But that's not all, right? So this data for this individual relates to other information that is claim information, insurance information, and lab test results in a healthcare scenario. And how are they connected? They're connected by this national ID or the social security number. That's the primary key on the top table, and the foreign key that is creating a reference for this other information. And when we're doing reporting and analytics, we're relying on this reference. So if we were to protect this data with traditional masking types of technologies, as you can see here with X's replacing some of the sensitive values, that looks fine. It looks like we're doing a good job of protecting the data. However, the referential integrity of the data is now broken. We don't know what lab tests, insurance information, and claims relate to what individuals. So it completely breaks the ability to analyze this data properly. So if we transform these tables using format preserving protection, we get something like this. So you can see that most of the columns in the patient table have been protected. We have calculated the year of birth. Instead of using the real date of birth, we can use year of birth as a value we can use in our analytics. But all the other columns you can see. But then in the claim, insurance, and lab test tables, there are just a couple of columns protected using format preserving encryption. So if we do it this way, now we have preserved the referential integrity of the data set. So this is ultimately what we mean by enabling data analytics with protected data. So let's talk about voltage secure data for the Snowflake Data Cloud. Back in March, we announced the partnership between Micro Focus and Snowflake about our abilities to protect data in this platform across a variety of cloud platforms. So what does this look like? This is a high-level reference architecture that shows the data flow from the left-hand side of where this data may originate, where it is stored and used in Snowflake, and how users access this data on the right-hand side. So let's have a look at this in the various stages of this data flow. On the left-hand side, we're talking about the source data. So many times data will be coming into Snowflake, and that data needs to be protected. There's a wide variety of tools that can be used, from traditional ETL tools to Hadoop-based environments to some Snowflake tools of their own. So all of these things are possible integration points to invoke the encrypt or tokenization functions using APIs or file processing. There's a wide variety of ways of addressing the protection of this data. Many times this will be done on-premise, or it could be done as it lands in the cloud. Those are matters of security, performance, and architectural preferences. There may be situations if a customer is already using voltage secure data for their on-premise systems, their business applications, that data may already be protected. And of course, in that situation, that data can flow as is into the Snowflake Data Cloud. There is a mention here of Voltage Structured Data Manager. That is one of our own capabilities to not only move data, but to actually discover and classify data in the source systems. So once data is now moved into Snowflake, we've done the protection. We've done the protection at the attribute level. That data can now be used for a large amount of an analytic value without requiring any additional software from Voltage to accommodate this. The protection has been done beforehand. That data is now safe in the Snowflake environment, and users can continue to operate and get value from the other attributes that are available in the clear. And as shown earlier, the referential integrity of those queries, those joins, is preserved. Now, we have to then accommodate for some users that have privileged access to actually re-identify, decrypt, detokenize this data. And this is enabled through the native capabilities of Snowflake, specifically the combination of masking policies with the ability to call an external function. So depending on the cloud platform, this could be AWS, Azure, or Google Cloud, they all have ways of integrating through their cloud API capabilities. And what we have then in combination with that integration is a Voltage Secure Data Cloud function. So in the AWS world, this will be a Lambda function, or it could be an Azure or Google function running in the virtual private cloud environment of the customer. And that will be using keys, encryption keys, from the Voltage Secure Data Key Server. So all of this works beautifully to provide the ability for certain users that have certain roles, the ability to decrypt, detokenize data quite transparently for their experience. They don't have to call these functions explicitly. That all can be automated in a transparent fashion through the masking policies native to Snowflake. In the demonstration, Neville will be showing it in a few minutes. We are showing a variety of information relating to the earlier sample I was showing that includes patient information, claim information, lab tests, and a few other things. And here we're seeing the different roles that Neville's going to demonstrate. From a research role, the user will be Rich. Carol, who's more of a caregiver in the healthcare scenario. We have a finance user, Frank, and we have the system administrator. You can see here that each one of them, via their role, has access to certain types of attributes and not others. And then there are examples here of quite a lot of attributes that remain in clear text because we have de-identified the private parts of those data sets, specifically in national ID values. We'll move now to the demonstration of voltage secure data on the Snowflake Data Cloud.
Thanks, Phil. So for this demo of SecureData with Snowflake Data Cloud, let's look at the following. So we have data. In particular, we have the 4 tables: claims, insurance, lab results, and patient. Then we have the 3 roles: care, research, finance, as well as a special user, the sysadmin user, who uses the ETL role. We are going to look at the care users who need access to the patient information to provide care. The care users do not need access to the PCI attributes like credit card number. The research users will have access to the patient zip code. Research users will be working on de-identified data, and it's important that the referential integrity is preserved. The finance users have access to the PCI-like attributes like credit card number, but do not have access to the PII attributes like name. And they also have ability to run reports on de-identified data. The ETL users, even though were the ones who created the data as well as the roles, after the masking policies are applied on the tables, will not be able to see the data in the clear. So let's have a look at this data. So here we are logged on to the Snowflake Data Cloud as the sysadmin user. We are going to do this so that we can look at the sample data. We have 4 tables. So let's start with the previewing of data from the claims table. We have claim number, national ID, claim type, claim status, and the amount column. And this is the data. As you can see, national ID is protected using obviously protected mode of encryption, where you will have a mix of alpha and numbers to easily tell that this data has been protected. In the insurance table, we have these columns, and let's look at the preview of the data in the insurance table. Again, national ID is consistently protected with obviously protected mode to help facilitate the joins. We look at the lab results. We have national ID, lab test results, and the date as the columns. And let's look at the data. We have national ID protected again, and then we have lab test like creatinine, the result. This is the number which was returned for the test, and this was the date when the test was performed. For the patient table, we have number of columns, and a number of them would be protected. We are going to look at them in a minute. So let's run this query as the sysadmin user. Here we are looking at the 10 records from the patient table. And if you notice, the first 3 are encrypted and the encrypted data is shown. The other ones, like date of birth, the zip code, and the credit card, are showing nulls instead of the encrypted data. This was done by choice, as date of birth, when protected, gives you another valid date, and it's very difficult to look at a date and see whether this is a protected date or the original date. The same is true for credit card numbers as well, and the zip codes. So we start with the care user. Remember, care user needs access to the patient data so that they can provide care. In this case, Carol happens to be a member of the care role. So if I run this query as Carol, And I'm going to look at the patient table similar to the query which we ran earlier. And you can notice here that for Carol, the first name and the last name is decrypted. She still does not have access to the zip code and credit card number. Oh, by the way, date of birth is also decrypted for the care users. So how can a care user use this information to run a query? In this case, we are trying to find a group of children who can play together or participate in outdoors activities provided they have a very low risk rating. So we are going to run this query. And here we found the first name, last name, the age of the children who have a very low risk and who can go out and participate in group activities and games. Now let's go to the other worksheet where we are going to look at user Rich who belongs to the research group. Being member of the research group, Rich does not have access to a number of columns. Rich only has access to the zip code. So let's verify that. So I'm again going to go to the patient table. And as you can see, the first three columns here are encrypted, do not have access to the date of birth or the credit card information, but my zip code is in the clear. How can I use this information to run some of my queries on the de-identified data? So here we are trying to find number of patients by zip code who have lab results greater than 35 for creatinine. So I'm going to run a query which might look like this. Here I'm going to perform a join on the patient table and the lab results table. The joint condition is going to be on my national ID, and I'm looking for the test like creatinine with the results having a value greater than 35. As you can see, this is the zip code and these are the number of patients. We could also find the patients with maximum claim amounts. So in this case, I'm trying to get the patient's first name and last name versus aggregating them by the zip code as we did previously. If you notice here, I can get the encrypted first names and last names. And because the referential integrity is preserved, I can always go back under policy control and request this first and last names to be decrypted for me. And here I can see this particular individual had a total claim amount of this. This is his age, and this is his risk rating. So let's go and see how this would be different for somebody who is in a different role. So in this particular case, I'm going to go as user Frank who belongs to the finance role. Let's run the same select star from query where we are trying to understand what user Frank can see. User Frank should be able to see clear text zip code and the credit card data. He should not be able to see the national ID, first name, and the date of birth. And that's exactly what we see here. How can I continue working with this de-identified data as a user Frank? For example, I want to find the total claim amount by an age group. So for this particular example, we are going to have 4 groups where we have retired, middle, lower middle, and millennial as the group based on the patient's year of birth. So let's run this query. When I run this query, it actually gives me an average cost by the age group. And in this particular case, it's millennial who have the average cost, highest average cost. Going back to how this all was started, ETL users, in this particular, the sysadmin group is my ETL user. And running this query, you were able to see that I do not have access to any of the protected information. The only thing I have access to is the clear text column, which is the year of birth for the patient table. Everything else is not accessible. Would I be able to use this information to work with the protected data? For example, for my ETL job, if I want to find out a user with multiple policies and their age, I can still run a query something like this on protected data, and I would be able to find out. As you can see here, the first name tells me this is the same user because the referential integrity is protected. So if you look at the rows 2 and 3, it's the same user. 4 and 5 is the same user again. And they happen to have the same last name, different first names, but the same last names. And then you can find the relevant information like the policy number, their age, and so on. How was all of this done? This was done by creating a current role. For example, we had 3 roles for finance, and then applying the masking policies for each role. So here I'm actually applying the masking policies by the role at the individual table level. So I'm applying the masking policies of PCI DECC, which is defined earlier on, to this particular table and giving access to a particular role on this one. So this is my alter statements where the masking policies are applied to the patient table. This is the masking policies applied to the claims table, the lab results table. Remember, this masking policy is applied so that nobody has access to the national ID number. Everybody is going to be using protected national ID numbers. And I can quickly see these policies by just running this show masking policy statement, and it will tell you which policy was applied for which table column. The functions which are used to protect look something like this. If I scroll up, I can see, is this a function used for protecting the national ID? And here, it's a very simple syntax where I'm creating a function, could call it whatever name I want. In this particular case, we are calling it VLT unprotect national ID because this is an access function. This is why it's unprotecting the data. I'm telling the operation type is access, and this refers to the voltage cryptid, which is used for protecting that data. As I said earlier, we are using an obviously protected mode so that we can look at it and differentiate that that's the protected value. Here we are creating a number of functions for protect and access. This is for credit card column. As you can scroll up, this is for date and then zip code, names, and so on. If you have any questions, feel free to reach out to Phil or I. Would be happy to help you with any of your questions. Thank you.